This is a lesson for Year 10 higher mathematicians. The topic is cumulative frequency, and it's lesson 6, cumulative frequency graphs 2. The group frequency table shows the heights of sunflowers in centimetres grown by a class of children. Explain how to use the group frequency table to find the median height of the sunflowers and the upper and lower quartiles. Now we remember in lesson 4 that we used, when we had a frequency table, we used a column called the cumulative frequency to help us find the median and the upper and lower quartiles. Now the cumulative frequency is very simply a running total of the frequencies, and the effect it has is to put all of the values in order. So in this case the cumulative frequency would be 7, 7 add 11 is 18, 7 add 11 add 6, 24, 27 and 30. So of these 30 sunflowers then, we know that the median is going to be the middle one of those. So for the median, if we do 30 divided by 2, that tells us that we are looking for the 15th value. Now the 15th value occurs between these two groups here. Okay, so from 7, these are the first 7 values, these are the first 18, therefore the 15th is going to occur between these. So we know the 15th value is going to be somewhere in this class interval. The problem is we don't know whereabouts within that class interval it is going to occur. Is it at 95, 105, somewhere in between? We just don't know. And we have a similar problem when we come to calculate the lower quartile. 30 divided by 4 tells us we're looking for the 7.5th value. And for the upper quartile, 30 over 4 times by 3 tells us that we're looking for the 22.5th value. Again, we know that the 7.5th value is actually going to occur somewhere between these two here, so it's going to occur in this class interval here. And we know for the upper quartile, which occurs in the which is the 22.5th value, it's going to occur somewhere in between here, so between 105 and 115. But we just don't know whereabouts within those class intervals these occur. Right, so how are we going to solve this problem? Well, we're going to do it today using a cumulative frequency graph. Okay, so for this example, the grouped frequency table shows the masses in kilograms of the fish caught by an angler one day in April. So what we're going to do, if we want to find the median for a grouped frequency table, is to initially complete the cumulative frequency column. Okay, so 5, 13, 17, 26 and 30. Some of the frequencies 30, cumulative frequency adds up to 30. So we are happy that we've calculated those values correctly. Now what we need to do is, if we want to find the median and the upper and lower quartiles, is to draw the cumulative frequency graph. So I'm going to turn over here, and we're going to plot the graph. Now the first group, the first class interval, goes from 2 to 4. So I'm going to plot 0 here at 2. And then I'm going to start plotting at remember the top end of each class interval. So if the first class interval is 2 up to 4, then I plot my cumulative frequency at 4. Okay, and the cumulative frequency is 5. For 4 to 6, the cumulative frequency it's 13. From 6 to 8, the cumulative frequency is 17. From 8 to 10, the cumulative frequency is 26. And from 10 to 12, the cumulative frequency is 30. And what I need to do now is join all those points up with a smooth curve. Remember, no rulers, no feathering. Okay, it's got to be a smooth curve going through all these points. Okay, like so. Now that I've drawn the cumulative frequency graph, I'll be able to find out these key values that I'm interested in. Now I know that if there are 30 values, that the median is going to be 30 over 2. It's going to be the 15th value. So if I've got my 30 values here and I find the 15th one and go across and down here like so, I can hopefully see that the median in this case is going to be equal to 7 kilograms. The lower quartile is going to be 30 over 4, which is the 7.5th value. So if I go and find the 7.5th value now on here, so this is going to be 7.5, there we go. Draw a line across and going down. I make that the median is going to be, if that's 5, that would be 4.6 kilograms. And similarly for the upper quartile, that's going to be 30 over 4 times by 3, means I'm looking for the 22nd.5th value. So the upper quartile, 22nd.5th. Is there, down, I think makes the upper quartile about 9.2 kilograms. Now I need to draw a box plot now to show the summary statistics, and what I can do in with the way this is set out, I can transfer the key values from here directly down onto the scale for the box plots. So if I draw in the lower quartile here, like so, the median of 7 and the upper quartile, I can draw those in like so, and I've got the middle part of the box plot is completed. The issue is, what are the highest and lowest values? Now remember, when we're estimating the range, we take the estimates to be the lowest possible value that the weight could take, and we take it to be the maximum value as well. So the lowest possible value that the fish could be would be 2 kilograms, and the highest possible value would be 12. And there is my box plot. Now finally, I want to make two comparisons between these. So the first comparison that I'm going to make is going to be using the measure of location, in other words an average, or the average in this case is the median. And I can see that here on average in April the mass of the fish is roughly 0.8 kilograms less than June. So I can write something like that down. So on average, the mass of the fish is 0.8 kilograms less in April than June. And now I need to compare a measure of the spread, and I can see I'm going to use the interquartile range here. Although I could use the range if I wanted to, but I'm going to use the interquartile range. You can see here that the interquartile range in June is significantly smaller than in April. And that means that the mass of the fish for the middle 50% of the data is less varied. I'm going to write that down here. So the mass of the middle 50% of fish is less varied in June. Just remember that when you do make these comparisons, it's always those two things that you need to consider, a measure of location and a measure of spread.